Yeah, maybe I will do Twitch. So next week, I mean, it's been YouTube Live has been kind of like I've been having more problems with YouTube Live than I have on Twitch the whole time, like last semester. Okay, so primary active transport. Let's talk about. So we just finished talking about osmosis. Let's talk about transport. So active transport. There are two broad types, and primary and secondary active transport. But let's talk about the difference between active transport and passive transport. What do we have here? So again, I like to draw this analogy. So passive transport is like putting your car in neutral and letting it roll down a hill. So what's happening is that you're actually going from a high energy state to a low energy state. And just due to gravity and all the potential energy built up by being on top of a hill, that allows it to be converted into kinetic energy that moves the car. Actually, that's too much physics. Don't worry. But I'd like to draw that analogy. It's easy to go from high to low energy. So when you put your car in neutral and let it roll down a hill, are you using any gas? You're not using any gas. So that's why it's passive transport. So that passive transport is like that. You don't need to spend any additional energy from the cell or any built up energy in the cell. Now, active transport. So say you have something reverse. So you're at the bottom of a hill, you put your car in neutral, but is your car likely to spontaneously travel up the hill if you don't use any gas? Again, you need gas to go up a hill, especially if you live anywhere on the mountains. If you live in Makakil, you know you spend a lot of gas. So that what you have to do is add energy. You have to add some sort of gas to push this car up the hill. And same with active transport. You need to spend some sort of energy to move something from low to high energy. So that's what active transport is like. Now, what's the example inside the cell? So again, remember that in general there are, or actually I don't think we covered this yet, but in the cell at rest, assuming that no ion channels are open, there's a higher concentration of sodium in the outside of a cell than on the inside of a cell. So if you open up an ion channel, what will happen? Well, remember, this is what we call facilitated diffusion. So facilitated diffusion will happen, and remember, diffusion always happens from high concentration to low concentration. So that's what's going to happen here with this facilitated diffusion through an ion channel. It's going to move from high sodium concentrations to low sodium concentrations. Now, what do we have? So the thing is that, can it go from low to high, just like that car going uphill? Well, the thing is that, why can't these sodium ions that are inside the cytoplasm join all the other ones in the extracellular fluid? Well, remember how I said positive attracts negative and negative attracts positive? Well, the thing is that like repels like. So positive charged ions, they like to repel, they actually like to push away other positively charged ions. Same with negative ions and negative ions. So what happens if you try to move these sodium ions this way, it happens just through some random motion. Well, things that all these sodium ions over here, it's going to actually repel this sodium ion that's trying to join them in the extracellular fluid. So this is why, again, it's easier for it to join it for a high concentration of sodium ions to join it where there's relatively less sodium ions pushing back, versus this way where you already have a lot of sodium ions in the extracellular fluid pushing back any sodium ions that try to go the opposite way. All right, so I'd like to draw this analogy. So say you have your closet or dresser, and what happens when you add your clothes to it? Well, if it's an empty closet, it's pretty easy to add your clothes to it. But things that sodium ions are kind of like that. As you keep on adding more and more into your closet, and your closet is full of clothes, it gets harder and harder to add more and more clothes to an already stuffed closet or dresser. So sodium ions, if you try to add more sodium ions to a solution or to the extracellular fluid, it gets harder and harder for the cell to add more sodium ions because they eventually start pushing back due to all those electrical charges repelling each other. So what happens? It eventually pushes back. So things that I know, speaking from experience, now I actually fold my clothes and do the whole Marie Kondo thing. But the thing is that, what do you have to do when you have so much clothes in your closet already? You have to add more energy, more force. So same with transporting sodium ions from the inside of the cell towards the outside. Since there are so many sodium ions already on the outside of a cell, as you keep on adding more and more sodium ions and pumping them out of a cell, you have to add more and more energy. So again, you have to add energy to move from a low concentration to an already high concentration. And this is why we call it active transport, because you're adding energy rather than just letting it happen by itself.